Morning, Nick. This is one of the first problems here, so let me explain the parts. So the speedometer of Ted's Honda is designed to be accurate with tires that are 14 inches. So question A asks you to find the number of rotations of a tire in 1 hour if the car is driven at 55 miles per hour. So the first thing you want to figure out is how far the tire has gone. So this is to calculate how far the tire's gone. You take your 55 miles per hour and then you have to convert the miles to inches. So you do 12 times 5280, which is feet per mile. And then once you know how far the tire has gone, you divide it by the circumference of the tire. Now, there's two possibilities here for circumference of a tire. It's 2 pi r, r being the radius, so in this case 14. If you use the pi button, you'll get an answer of, so using the pi button, you get 39,615.94. That's if you use the pi button. If you use 3.14 for pi, you get 39636.03. So you may want to ask your teacher if you're going to be using the pi button to get an exact answer, or if you're using 3.14. So that's the first question. Okay, on the next question, the idea is that the radius is 3 inches, since it says that the minute hand is 3 inches from the center. So the radius is 3 and the circumference is 2 pi r, which makes the circumference 6 pi. So a rotation of 30 minutes. 30 minutes is half an hour. So at 30 minutes, it will have traveled half the circle. So you take half the circumference, and that's equal to 3 pi. So that's how far it would have traveled. 6.5 hours means that literally starting at that point, you will have gone around 6 full rotations and then another half of rotation stopping here again. So that would just be 6.5 times 6 pi. So that would be 39 pi. And not sure if he wants it in decimal answers or not, but at that point, you could convert that to a decimal if you needed to. Okay, this next problem is the pendulum problem, is what we call sector length problem. And what you're doing is you're looking at how long a small part of the circumference is. So that formula is the measure of the angle. In this case, the measure of the angle is 20 degrees over 360, because that's how many degrees are in the whole circle. So you're taking a fraction of the circle, and then you're multiplying it by 2 pi r, which is the circumference of the circle. R is the radius, and in this case, the radius is 40. So if you multiplied that out, you'd get 40 pi over 9, or if you convert that to a decimal, it's 13.96. And I believe this is in inches, so you probably need to also include the unit of measure. And it actually does say to round it 2 decimal places in the problem, so they are looking for a decimal answer here. All right, going with what you started off with on your paper, the first thing you seem to do is to convert your feet to miles, which is fine. Then you have 180 rotations per minute, so you converted those rotations per hour. But then what you needed to do was figure out how many that was, and that's where using the circumference of the circle comes in. So it's 2 pi times that the rotations per hour times your mileage, and that gives you how far it will go in radians per hour. So don't forget that you have to go all the way around the circle. And so that's why you have to multiply it by 2 pi. Okay, here are the questions that I'm just going to have to write in myself. This one here says you have a triangle that's in a third quadrant, so I'm going to draw it in the third quadrant. Tells me that the tan of theta is root 7 over 3, so that would be opposite over adjacent. So the opposite side is root 7 and the adjacent side is root 3, which makes the hypotenuse here 4, and I get that by using the Pythagorean theorem. So they want the secant, which is the reciprocal of cosine, so that's going to be hypotenuse over adjacent, so that's 4 over 3, and because I'm in the third quadrant, my answer is going to be negative 4/3. Okay, for this one we have a triangle that's in quadrant 2. They're telling us the cosecant is 2 over 1, so that's your hypotenuse and your side opposite. That's reciprocal of sine. So that's 1 and 2. So you have to find the adjacent side, which turns out to be the square root of 3. They want the 5 remaining, so you've got sine of theta, cosine of theta, tan of theta. And then we have the cosecant of theta, which they already tell us is 2, secant of theta, and then cotangent of theta. So the sine of theta is going to be 1/2. The cosine is going to be adjacent over hypotenuse, so that's root 3 over 2, and the tangent is opposite over adjacent, so that's 1 over root 3. What you do need to remember is that your cosine and your tangent are negative because I'm in the second quadrant. For the secant, we just want to take the reciprocal of the cosine, and then for the tangent, they want you to take the cotangent, you take the reciprocal of the tangent. Now, I believe on one of the sheets you had the other day, your teacher said they wanted you to rationalize the denominator. So just using an example like negative 1 over the square root of 3, to rationalize, I'm going to multiply both the numerator and the denominator by root 3. And that's going to give me negative root 3 over 3. Also, if you're using your TI X30S, that will rationalize it for you. All right, on this question, Nick, it says to show that the cotangent of beta over sine of beta is equal to cotangent beta. Technically, that's the definition, but if you needed to show a few steps, what I would do is I would leave this side the same and manipulate this other side over here where it says cotangent. And the way you could manipulate it is you could say that cotangent is really 1 over tangent. Let me get my pen's not working. 1 over Okay, so I would leave the cosine beta and sine beta side the way it is, and I would manipulate this other side here. So I'm going to make this 1 over tan beta, which would be 1 over sine beta over cosine of beta, which is equal to cosine beta over sine beta. And I think that's what he's looking for. It's a little hard because that's one of the direct reciprocal functions that we know. All right, so on a problem like this, the first thing you want to do is find the missing angle, and that you just do because all 3 angles are equal to 180 degrees. Now, to find the side lengths, 2 things you want to keep in mind. First of all, since these were given in degrees, make sure that the mode of your calculator is in degrees. And the other thing is you always want to use the given information. So based on the given angle and given side, what function should you use? The first one to find side A, that's going to be opposite over adjacent, so that's your tan function. And then to find side C, that's adjacent over hypotenuse, so that's going to be your cosine function. And then there are your answers. I didn't see where it said what decimal place to round it to, so I was just consistent since he had it to the 10th place. All right, so in this one, you're given the coordinates -8, 15, which puts you into the second quadrant. So you have a triangle that's set up like this. The first thing you want to do is find the missing side, which is the hypotenuse. That has length of 17 when you do Pythagorean theorem. That then asks you for all 6 of your trig functions. So your sine is going to be opposite over hypotenuse. Your cosine is going to be adjacent over hypotenuse. And then your tangent is going to be opposite over adjacent. What you do need to keep in mind is that you're in the second quadrant, so cosine and tangent are negative. The cosecant, secant, and cotangent are just reciprocals of those functions. So once you have the first 3, you can just take the reciprocal. And there are no radicals here, so there's nothing to rationalize in this problem. Okay, so all of the other problems that you sent me it was the worksheet that we had already gone over. So if you still have any questions on any of those and you want me to redo them, I will. The video length can only be 15 minutes and we're at 13 minutes, so I wouldn't be able to go over all of them right now, but you can send them to me and I can make you a super quick video. I'll be at my desk all day today, so let me know. Good luck. I know you're going to do awesome.